All right, welcome to day 7. We're officially at the halfway mark of our AI series, and today we are tackling the big one, deep learning. This is the engine that's driving pretty much the entire modern AI explosion. Now, I know it's a term you've heard a million times, but by the end of this, you're not just going to know what it is, you're going to get the why and the how behind this seriously game-changing tech.
So let's just jump right in with this. A pretty simple neural network, maybe one with just a couple of layers, can learn to recognize handwritten numbers. And that's pretty cool, right? But what happens when you don't use 2 layers? What if you stack over 100 of them? Well, then you get a system that can drive a car, write poetry, and beat the best humans at the most complex games ever created. So what's the secret? What actually happened when we decided to go deep?
Okay, so what does that word deep in deep learning even mean? Well, it turns out it's a little more complicated than just piling on more and more layers. But honestly, that incredible depth is the perfect place for us to start. So the term deep is actually pretty literal. It refers to the number of hidden layers inside the neural network. A shallow network might have just 1 or 2 layers, and it's great for learning simple patterns. But a deep network, we're talking tens, hundreds, sometimes even thousands of layers. And that's what allows it to learn these incredibly complex, incredibly abstract patterns from the world. It's the difference between seeing a 7 and starting to actually understand what a face is.
But, and this is so important, it wasn't just about adding more layers. That alone wouldn't have worked. The whole deep learning revolution was kind of like a perfect storm of breakthroughs happening all at once. We needed totally new types of networks, or architectures, designed for specific tasks. We needed just insane amounts of data to feed them. We needed specialized hardware, like the GPUs in gaming computers, to do all the math. And we needed much smarter ways to train these giant models. All of those pieces had to fall into place.
So why does having all that depth make such a huge difference? Well, the answer is this really cool concept called the feature hierarchy. And what's so wild about it is that it's kind of how our own brains seem to figure out what we're looking at.
Let's just walk through it.
Imagine you show a deep network a picture of a face. That very first layer, it doesn't see a face at all. It just sees a bunch of pixels. And from that, it learns to spot the most basic things, like simple lines, edges, and points of contrast. Then the next layer up takes those simple edges and combines them into basic shapes, things like curves and corners. Then that gets passed up to the next layer, which starts assembling those shapes into recognizable features, like an eye, or a nose, or a mouth. And finally, the layers at the very top put all those features together to recognize a specific person's face. Each layer builds on the last, getting more and more abstract as it goes.
And that is the feature hierarchy in action. It's how an AI takes an impossibly complex problem and breaks it down, layer by layer, into smaller, simpler, manageable steps. It's fundamentally how machines are learning to see.
Now, it's really easy to think of deep learning as just one single thing, but it's not. It's much more like a toolkit for a specialist, It's filled with different, very powerful, highly tuned instruments designed for very different kinds of jobs.
First up, in the toolkit, you've got CNNs, or convolutional neural networks. You can basically think of these as the eyes of AI. They are absolute masters at processing visual information. So self-driving cars seeing the road, medical AI spotting tumors in scans, your phone recognizing your face, that's almost always a CNN at work.
Then you have transformers. These are the undisputed brains of modern AI. They are the engine behind things like ChatGPT. Their secret weapon is a concept called an attention mechanism. It basically lets the model look at an entire sentence or paragraph at once and figure out how every single word relates to every other word. It's how AI finally cracked the code on understanding context, and it was a total revolution.
And just to round out the kit, you also have things like RNNs, which act like the AI's memory, making them perfect for things that happen in a sequence, like speech or stock market data. And then you have GANs, the artists. These are wild. They work by having 2 neural networks compete against each other, one trying to create fake data and the other trying to spot the fake, until the results are stunningly realistic.
So with all these incredible tools, you might think deep learning is the perfect solution for every problem out there. But it's really not. And honestly, knowing when not to use it is just as important as knowing when to pull it out of the toolbox.
So here's a good rule of thumb. If you've got a massive data set, we're talking millions of examples, and a really complex, messy problem like understanding images or human language, deep learning is your best bet. But if you have a smaller, more organized data set, like something you'd find in a spreadsheet, a more traditional machine learning model is often way better. It'll be faster, more efficient, and a whole lot easier to understand what it's doing.
I love this analogy because it just hits the nail on the head. You don't use a sledgehammer to hang a picture frame. It's a perfect reminder that sometimes the biggest, most powerful tool isn't the right one for the job.
Okay, for our last section, let's just step back for a second and appreciate how incredibly fast all of this has happened. I mean, we are not talking about a slow, gradual change. This was a full-blown technological revolution that pretty much unfolded in just over a decade.
Just look at this timeline. In 2012, a model called AlexNet completely demolishes the competition in a big image recognition challenge, and suddenly, deep learning is on the map. Just 4 years later, AlphaGo beats the world champion at Go, a feat experts thought was decades away. Then in 2017, the paper that introduced the transformer gets published, setting the stage for everything to come. And by 2022, tools like ChatGPT and Stable Diffusion put this incredible power into the hands of millions of people. The pace is just breathtaking.
So we went from a niche, quiet corner of computer science to a world-altering technology in about 14 years. And it really just leaves you with one massive question. If this is what happened in the last 14 years, what on earth will the next 5 look like?